You're welcome to my channel. So today I want to look at two questions and I would like you to tell me the one you find difficult between the two and the one that is most interesting between the two questions. So let's see, the first question is x plus y equals 72, and the second one is, it's still simultaneous equation. So x raised to power 1 over 3 plus y raised to power 1 over 3 equals 6. Here is equation 1 and here is equation 2. So that's the first question. And the second question tells 3 to the power of n minus 2 to the power of n equals 65. So here are the two questions. You can pause the video and give it a try and tell me the one you find so interesting between the two questions, and when you're done you can keep watching the video. Alright, so for the first one I have x plus y to equal 72, and I have x to the power of 1 over 3 plus y to the power of 1 over 3 equals 6. Now the question is, how should I go about this? Very simple, it's a simultaneous equation, right? And I can use substitution method by making x the subject of the formula from equation 1. So I'm going to be having x equals 72 minus y. Don't try this at home. If you try that, there will be a problem, because here that we are going to substitute it in, we are having a fractional index, which will make it kind of complex. So let's see how we can get rid of this fractional index and then see how we can come about the solution from there. So I'm going to say let p equal x to the power of 1 over 3 and then q equal y to the power of 1 over 3. So from here I have that x equal p cubed and then y equal q cubed. So we can then rewrite the equation in terms of p and q instead of x and y. So for that reason, I'm going to be having x plus y to become what? P cubed plus q cubed equals 72. And this will be my new equation star. And the second equation will become p plus q equals 6. And this will be equation star star. So here now we can do what we want to do initially by saying from equation star star p equals 6 minus q, and that will form equation star star star. So put equation star 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 into equation star. So why we are putting it into equation star is because we use equation star star to get equation star star star. So we can't put it back into that equation, otherwise we are going to be parabolating and we might not be able to move forward. So for that reason, put it into equation star, then equation star will become what? P cubed, right? That will be 6 minus q all raised to the power of 3, but don't let us go down because we are still going to have another difficulty in the sense that I'll be having 6 minus q or q. And I want to factorize this, which is going to make my problem kind of complex. So let's see how we can do it very smart. And what's that? Let's apply algebraic identity to this. Applying algebraic identity to this one, we are going to be having what? P plus q into brackets p squared minus pq plus q squared equal 72. Are you there? So we can rewrite this again to become p plus q into p plus q all squared minus 3p cubed. So if we have this, this will equal 72. Can you see that now? So that means I don't necessarily need to put this into this equation any longer. Why? Because p plus q is equation star star, and then I have it to be what? 6. So just slot it into this equation, and then we have 6 into 6 squared minus 3, so that's there won't be a mistake here. So let's see. So let's make this 6 into bracket 6 squared minus 3p cubed equals 72. So the first thing, divide both sides by 6. We therefore have so when you divide both sides by 6, we are going to be having 6 squared, which is 36, minus 3p cubed equal 72 divided by 6. So 72 divided by 6 is going to give us what? 36 minus 3p cubed equal, this will give us 12. Am I right? Yeah. So because 6 in 7, that's 1. Then 6 in 12, that's 2. So we are good to go. We can now collect the like term. So we have 3p cubed to equal 36 minus 12. So we have 3p cubed to equal 36 minus 12 is going to give us what? 4, and that's 24. So p cubed equal 24 divided by 3, and that will give us 8. So we have a very new equation now, that is p cubed equal 8. Call this equation star, star, star. So equation star, star, star can be useful now, right? So we just say put equation star, star, star into star, star, star. So that means anywhere we find p, we replace it with what? 6 minus q multiplied by q equal 8. And this will be 6q minus q squared equal 8. So collect the like terms. You have q squared minus 6q plus 8 equal 0. And then we can solve this equation quadratically now, right? So to solve the equation quadratically, we are going to be having what? Q squared minus 2q minus 4q plus 8 equal 0. Of course, you know how we get that. So looking for two factors that when you multiply them together, you are going to have 8q squared. When you add them together, you have minus 6q, and that's minus 2q minus 4q. So this will become what? Q into what? Q minus 2, because q is common here, and the minus 4 is common here. Factorize it out, then we have q minus 2 equals 0. So q minus 4 equals 0, or okay, let's take it like this. Let us jump. So q minus 2 multiplied by q minus 4 equals 0. So from here, q equals 2 or q equals 4. Since we got the value for q now, we can get the value for p, right? So fine. So we just say, recall that p equal what? 6 minus q. We therefore have that p equals 6 minus 2. So let's take it like this. When q equals 2, then p equals 6 minus 2, and that's 4. And when q equals 4, then p equals 6 minus 4 equals 2. So we have a set of value for p and q. So p equals 4 when q equals 2, and p equals 2 when q equals 4. But we are not looking for the value of p and q. What we are looking for is the value of what? X and y. So we recall that p equal x to the power of 1 over 3, and q equal y to the power of 1 over 3. So if you cube both sides to cancel this fractional power, you are going to have p cubed equal x, and q cubed equal what? Y. So our p is 4. We are going to have 4 to the power of 3 equal x, and we are going to have 2 to the power of 3 equal y. Therefore, x equals 64 and y equals 8. So that is our answer. And also, if x equals 8, then y will become what? 64. So let's check if it is right or wrong. So the equation is x plus y equals 72. X raised to power 1 over 3 plus y raised to power 1 over 3 equals 6. Awesome. So 64 plus 8, that's 72, correct. And 6 raised to power, 64 raised to power 1 over 3 plus 8 raised to power 1 over 3, that's 6, because this is going to give us what? The cube root of 64, right? And that is 4, plus the cube root of 8, that is what? 2, and that's 4 plus 2, that makes 6. So that's the solution to the first one. So compare it with what you've done. Do you actually get it right? Alright, that's not the actual issue for this class. We want to know the one that is very easy between the two equations. Is it the first one or the second one? So let's check the second one now, right? So for the second equation, it is very, very easy for you to get what the answer will be. This is 3 to the power of n minus 2 to the power of n equals 65. Wow. Very easy to guess, right? N should be 4, because 3 to the power of 4 minus 2 to the power of 4, that should give us 65, because this is 81 minus 60, no. 2 raised to the power 4 should give us 32, right? That's 2 times 2 times 2 times 2. 2 times 2, 4, 4 times 2, 8, 8 times 2, what's happening? Now, 3 times 3, 9. 3 times 3 is 9, right? Then multiply by 3, that's 27. Multiply by 3, that's 81. Then 2 to the power of 4, that's 16. Yeah. So that will give us 65. Awesome. So it means we guess right. But how can we get that 4? Let's see. This is kind of complex. Yeah, it's complex, absolutely complex. But we have an int. We already know that n is an even number. So for n to be an even number, and I have a negative value here, then I know this equation can exist as difference of 2 squared. Right? Yeah, it should be. Okay, so let's see how we can what? Express this equation as difference of 2 squared. And for me to do that, I'll say, let 3 to the power of n over 2 to be multiplied by 2. Can you see that? You know, if I have 3 to the power of n over 2 multiplied by 2, it's the same thing as 3 to the power of n. So I've not changed anything, right? It's just like I'm multiplying by 1 over 2 and then multiplying by 2 again. So that's cool. So let's say this one is p. And then 2 to the power of n over 2 multiplied by 2, that is what? Q. Am I making sense now? So, if that should be the case, let's use this to represent this equation. What do you mean? No. They're rubbish. Yeah, that's not correct. It's not going to work. Let's see. Let's rewrite 3 to the power of n as 3 to the power of n over 2 all squared, and 2 to the power of n to be 2 to the power of n over 2 all squared. Yeah, and then I'm going to have 3 to the power of n to become 3 to the power of n over 2 to the power of n minus 2 to the power of n will become what? To the power of 2. And this will be what? 2 to the power of n over 2 all squared equals 65. So let's p equal 3 to the power of n over 2, and then q equal 2 to the power of n over 2. Do you know that P and Q are so good because they save us in the 2 questions now? So come back to this now. So this will become what? P squared minus Q squared equals 65, right? So this will be what? Difference of 2 squared now. So P plus Q into P minus Q equals 65. Here is product. Can we express this as a product also? Yes. So 65 can be written as what? 13 multiplied by 5. Yeah, so P plus Q is 13 and P minus Q is 5. Yeah, our answer. You want to ask, why can't P plus Q equal 5 and then P minus Q equal 13? We know when 2 numbers added together, their value tends to be greater than when they are what? When we are taking their difference. For that reason, we have P plus Q equal 13 to be our equation star, and then P minus Q equal 5 to be our equation star. So, if you have the 2 equations together, I'm going to have 2P equal what? 18. and then P equal 9. So if P equal 9, we can then find the value of Q. So I'll say this is equation star, star, star. And I'll say put star, star, star into star, star. So for that reason, I will have that 9 minus Q equal 5. Then Q is equal to 9 minus 5, and then Q equal 4. So since we've gotten the value for P and Q, we can get the value for what? The value for N now. So then recall that P equal 3 to the power of N over 2, and then Q equal 2 to the power of N over 2. So P is what? P is 9, so we have 9 equal 3 to the power of N over 2, and Q is 4. We have 4 equal 2 raised to the power of N over 2. So this can be written as what? 3 to the power of 2 equal 3 to the power of N over 2, and this can be written as 2 to the power of 2, then 2 to the power of N over 2. So this and this will cancel, this and this will cancel also. Both sides we are having 2 equal N over 2, 2 equal N over 2. Cross multiply, N equal 4, N equal 4. And that is awesome. I know this one seems shorter, right? But it's more difficult than the first one. Catch you guys in the next video.